guys, here's the equilibrium lecture you've been anxiously waiting for. Le principle says that when a stress is applied to a system, the system will change whatever needs to happen in order to relieve that stress. Stresses come in the form of concentration, temperature, pressure, and in solids, liquids, and inert gases, meaning your notable gases, do not affect the system at all. And you saw what happens with changing of a system when you're working with Le Chatelier's principle lab, where you had your you had cobalt. Oops. Guess it would help if I used a color other than white. Cobalt compound, and this was the pink one. And chlorine. I think it was 4 of those. Going to your cobalt chloride and water. And this was the blue. So when you added hydrochloric acid, you added chlorine ions, and it became blue. The next thing that you did, or one of the other things that you did, is you added silver nitrate, and when you added the silver nitrate, that removed chloride ions in the form of silver chloride, and it turned pink. So it shifted to where you had more of the pink stuff. Another thing that you did is you added acetone. Well, what acetone does is it removes water, and so where you were adding the acetone, it ended up becoming the blue system. Calcium chloride. You added calcium chloride ions. Let's get another. So when you added the calcium chloride or chloride ions, it also started turning blue around the solid pieces. Then the last thing you did is you heated it up and cooled it down. When you heated it, it turned blue. I guess we need to have a different color here. Let's go with red. You heated it. When you added heat in, it became a blue system. And when you cooled it down, you're removing heat, and it became pink again. So that means that it was an endothermic reaction, meaning in order to add heat, to get it to go to the other side. When you removed heat, it returned to that pink. So let's do some quick practice. Okay, if we lower the temperature here, that means that we're removing the heat, and what's going to happen is the reaction is going to shift to the reactant side. So let's shift up here. Meaning that it is going to try and replace that heat that is removed from it. Okay, if we increase our pressure, increasing pressure means it's going to go to the side with the least number of gas moles. So you can see that you have 1 gas mole here, and we're going to a total of 2 gas moles. So the reaction is going to shift to the reactants to try and lower the effect of the pressure. If we decrease the pressure, then it would go to the reactant side because it has more than enough room for everything to exist in that system. If we remove hydrogen, so we're taking away from our hydrogen, the system is going to shift in order to replace the hydrogen. So it's going to go to the product side. Quite the opposite. Looking for a color I have not used. If we add hydrogen into the system has to relieve that addition, and it's going to go to the reactant side. In order to maintain the equilibrium constant, and we're going to talk about the constant in just 1 second. And the last thing, if we added neon gas, it has nothing to do with the reaction at all. So it has no effect. So you're not going to have any change whatsoever just by adding neon gas because it has nothing to do with it. So let's do a quick calculation. When you're doing your calculations, as you saw in your chemical equilibrium POGL, it's your products over your reactants raised to their coefficients. So in this case, NH3 is our product. It has a 2 coefficient, so that's a power in our calculations. We have nitrogen raised to the first, and then hydrogen cubed. So then we're just going to substitute in our different amounts. Our amount for ammonia is 0.1, and that's squared. Our amount for nitrogen is 0.25, and our hydrogen is 0.15, and that's cubed. When you're putting everything into your calculator, you want to make sure that you put the bottom into total parentheses to get the right answer. And when we do this calculation, it comes out to 11.85, and our constants here have no unit whatsoever. So this is one of those rare moments that you can just give me a number, and that's it. Now, your equilibrium constant is based on a specific temperature. At a given temperature, it's 11.85. At another temperature, it can be higher or lower depending on which part of the reaction it favors. And we'll talk about favors when we're going over this. Actually, let me go ahead and say that. When I say that it favors the reaction, it favors, in this case, you have a whole number, so your products are favored, meaning more products are going to be produced. If it's a decimal, then that means that your reactants are favored. Because if you think about it, you've got your numerator and your denominator. Your numerators are your products, your denominators is your reactant. So if you've got a decimal number, then that means that your denominator is larger than your numerator, giving you a decimal. So decimal numbers, your reactants are favored. Okay, so that is equilibrium in a nutshell. See you in class.